Partial differentiation, the very most important chapter in the Mumbai University syllabus. Okay, so partial differentiation consists of four types. The first type is basics, second type is using standard rules, third type is using composite function, and the fourth type is using implicit functions of 2 and 3 variables. So these are the four types we are going to study in detail in my further videos. So keep watching the video till end and you will get a clear cut idea about the partial differentiation. My first type of partial differentiation consists of basics, where only one step is required to be understood. So my first step is consider one variable at a time and assume another variable as a constant. The function will be given x, y square and all. So I will consider x. If I am differentiating with x, then I will consider x at a time and my y will be treated as a constant value. Okay, so let's see an example that z is equals to 2x square y. So here now we have to find the partial derivative, which is known as dou z upon dou x, which is equals to 4xy. Now the power in this, the x power shifted towards the left, which is how we take the derivative of normal terms, and my y was treated as a constant. Similarly, when we find dou z upon dou y, then my 2x square was treated as a constant, where derivative of y was 1. Now if we have to find the second order derivative from the first order, which was 4xy, now my second order will be 4y, where x was 1, and my second order derivative of y was 2x square, where y was absent. That's why my second order derivative becomes 0. So by using these method of basic, we will implement it in all the types of partial differentiation. I will be taking two or three examples about it as well. So keep watching the video. Now moving on to the next type of partial differentiation using standard rules. So what are my standard rules? So first we will move towards the standard rules and their formulas. So my standard rule is if z is equals to u plus minus v, like addition of two variables or subtraction of two variables, then dou z upon dou x can be written as dou u upon dou x plus dou v upon dou x, and dou zy equal dou z by dou y can be written as dou u upon dou y plus minus dou v upon dou y. For I will repeat it once again, dou z upon dou x equals to dou u upon dou x plus minus dou v upon dou x, and dou z by dou y can be written as dou u upon dou y plus minus dou v upon dou y. Now if z is equals to u into v, then dou z upon dou x can be written as u dou v upon dou x plus v dou u upon dou x. Dou z upon dou y can be written as u dou v upon dou y plus v dou u upon dou y. And if z is equals to u by v, then v can be dou z upon dou x can be written as v dou u upon dou x minus u dou v upon dou x whole divided by v square, and dou z upon dou y can be written as v dou u upon dou y minus v dou v upon dou y the whole divided by v square. So using these standard rules we will be implementing in my further 4 types of standard rules, which is based on algebraic expression, first order of function, second order derivative of a function, and Laplace equations. So these are the 4 subtypes of partial differentiation using standard rules, where we will be requiring about my standard rules. Okay, so keep watching the video till last to get a clear-cut idea about the how to implement partial differentiation using standard rules. Now moving on to the first subtype of partial differentiation using standard rules is using algebraic function. Now this subtype is very similar to the type 1, which was basics, but the difference here is here we have been given with proof or show that. So after finding my partial differentiation, I have to manipulate my result to get the asked result. So this was in the algebraic expression type. I will be solving sums on this type, so you will get a clear idea about the subtype of partial differentiation using standard rules. So keep watching the video till end. Now my second subtype of partial differentiation using standard rules include the first order of a function. How to find first order of a function, which is very similar to the basics, and the last type which I discussed was algebraic expression. So here we have to find the partial derivative similar to that both. Now here we will be dealing with trigonometric functions. So I will consider one function at a time, treating another as constant, and will simplify the sum using partial differentiation, and after that manipulation according to my proof which we have been asked in the question. So for better understanding, keep watching the video till end. I will be taking some examples for a clear understanding about these type of questions. Now, moving on to the third subtype of the partial differentiation using standard rules is the second order derivative of a function. Now for solving such type of questions, we need to understand, or we need to consider only two steps. The first step is finding the first order partial differential derivative, as we found in the first type and the second type. But now we have to find the partial derivative of obtained first order. Now here I am representing that dou 3 upon u can be is a function of dou x, dou y, dou z. So while for such sums, we first consider the most right derivative first. Like first we will differentiate u with respect to z, then by y, then by x for such type of questions. If it is written as dou 3 upon u whole divided by dou x, dou y, dou z. So first we will differentiate with u, then with y, then with x. Okay, or in simple terms I have written here dou u upon dou z. First we will find the differentiation of that, then that function will be obtained, then with respect to y the function will be obtained, then with respect to z for second order and higher order functions. So in this type of function we will be dealing with single functions or with multiple functions. So I will be taking an example for you to get a clear idea about this type of questions. So keep watching the video till end for a better understanding about the second order derivative of a function of partial differentiation using standard rules. Thanks. Now moving on to the next subtype of partial differentiation using standard rules is sum satisfying Laplace equation. Now for such type of sums we have to find the first order, second order and satisfy the Laplace equation, which is dou u upon dou x square plus dou y upon dou y square plus dou u upon dou z square equals to 0. In simple terms, we have to find second order derivative of u with respect to x, second order derivative of y with respect to y, second order derivative of u with respect to y, second order derivative of u with respect to z, and the addition of these three should be 0 for satisfying the Laplace equation. If it is not, then it is not a Laplace equation, and if it is, then it is a Laplace equation. I will be considering sums on this type of question, so keep watching that video till end and you will get a very clear idea about the topic. Now moving on to the next type of partial differentiation, which is using composite function. Now for composite functions, I have been drawn two diagrams for two variables and three variables. Now the upper apex of the square, which is towards the function z is equals to f of x y, represent my function, whereas the opposite point represent my answer. So when I have to reach that point, I have two ways, by using x or by using y. So by using, I cannot go directly to that point, so we need intermediate steps, where my first step will be partial derivative, and the second step in that route will be a normal derivative with respect to x. So I will first convert the function into a partial derivative form, and after converting the partial derivative form function, I will take the derivative of function, and I can reach dou z upon dou t. Okay, the same applicables to the next route, which is using the y route if the variable contains two variables. So the y route will be as similar to the x route just I discussed, which is dou z upon dou y and then dou y upon dou t. So from these intermediate steps, we can find the value using first by partial derivative and then by normal derivative. Now if the function consists of three variables, then the whole scenario will be the same, but the number of roots will increase as the variable increases. So depending on these two, there are two types, the first order and the second order. We will be dealing with both in my further video, so keep watching the video till end and you will get an idea about the first order and second order of composite function, the third type of partial differentiation. Now moving on to the first subtype of the composite function is using first order derivative. Now for finding first order derivative, when my z is equals to f u of v, u and v are my variables and z is the my dependent variable on u and v, which are independent variable. Now when I have to find dou z upon dou x, so how will I found my desired value dou z upon dou x, which is my intermediate step in my whole route, which I discussed in the introduction. So for finding that dou z upon dou x, we have a formula. For dou z upon dou y, we have a formula. So what are they? Dou z upon dou x can be calculated as dou z upon dou u into dou u upon dou x plus dou z upon dou v into dou v upon dou x. So I will get dou z upon dou x. Similarly, if I have to find dou z upon dou u, dou z upon dou v, dou z upon dou y, sorry for the mistake. Dou z upon dou y can be calculated as dou z upon dou u into dou u upon dou y plus dou z upon dou v into dou v upon dou y, and we will be getting dou z upon dou y. After calculating dou z upon dou x, dou z upon dou y, we will substitute in the root. So I will get half of the root, like I will get dou z upon dou x. Now after doing this, I will take the derivative and get the required answer. So it will help me to get through the half of the step, that is reaching the intermediate step. But after intermediate step, we have to take the normal derivative. So keep in mind this and you will understand about the composite function of first order. I will take an example, so keep watching the video and you will get a clear idea about the first order composite function of partial differentiation. Now moving on to the second subtype of composite function of partial differentiation, we have to follow only the three steps. The first step includes we have to find the second partial derivative, that is finding the first partial derivative and finding the partial derivative of the first order, and so we will get the second order partial derivative. After finding the derivative, we have to assume the function f of xy to u equals to u, and then prove according to the required equation that we will be need for in the question. So after following these three steps, we'll get our required proof that we are willing to have. So I will be taking an example which will clarify all the doubts in the steps. So keep watching the video till end of second order composite function of partial differentiation. Now moving on to the fourth type of partial differentiation, which is differentiation of two variable or three variable implicit functions. For two variable, we have to first find dou f upon dou x or dou f upon dou y, where f is the function. After finding the partial derivatives of function with respect to x, with respect to y for two variables, and with respect to z for the third. After finding these three, we have to find dy by dx, which is equals to minus fx upon fy, which should be equals to minus dou f upon dou x, the whole divided by dou f upon dou y. And after that, if it is further differentiable, then we will form dy by dx form, and we will get our answer for two variable. Similarly, for three variable, dou z upon dou x should be equals to minus fx upon fz, and dou z upon dou y should be equal to minus fy upon fz. So by doing this, we can simplify our implicit function and get the differentiable value of this implicit function. So I will be taking example on both two variable and three variables. So keep watching the video for a better understanding till last of differentiation of three or two variable of implicit function of partial differentiation. And for notes, like my Facebook page, Instagram page, and get notes on my Facebook and Instagram page. So you can download it and yes, share it among your friends, because a friend in need is a friend indeed. So like, share, subscribe my video and keep watching.